we begin with equation solving. To solve the equation 2 over x plus 4 equals 12 over 5x plus 1, as we always do when we have denominators, we multiply by the common denominator. Being careful to make note of the fact that we've done so, because when we do that, we eliminate from further consideration any values of x that make those denominators 0. In any case, the reason for that is because if we multiply both sides of an equation by 0, we invalidate everything else that we do. So anything that happens when the common denominator is 0 is totally invalidated. So we exclude those numbers from any solutions that we might get. Multiplying by the common denominator, the operation is fairly straightforward. We multiply both sides by the common denominator, which is 5x. Common denominator 5x and x is just 5x. And we distribute through and we get an equation that we can solve by the usual methods. The second equation is a quadratic equation in standard form with the equals 0 over here. And we solve this by simply substituting into the quadratic formula. We get a negative under the radical, and our solution here is to say that there is no real solution to this quadratic. On the other hand, if we have a quadratic x minus 2 times x plus 7 equals 0, you know, if you multiply this out, you do have a quadratic. You could multiply this out and use the quadratic formula. That would be unnecessary, though, because when you multiply two numbers to get 0, one of the numbers or the other has to be 0. So we get a solution to this when x minus 2 is 0 or when x plus 7 is 0. And the solution is either x equals plus 2 or x equals negative 7. The next quadratic equation is this one. Now this might not look like a quadratic, but it is. If we subtract the 3x minus 2 from both sides, we get this. This is a quadratic in standard form, and at this point we say etc. We simply proceed to use the quadratic formula. Of course, if we can factor it, we can use that 0 property, and that's something we always want to look at because sometimes it saves a little bit of time. Okay, now we have x minus 2 times x plus 7 equals 3. Can we do like we did before, say x minus 2 equals 3 or x plus 7 equals 3? No, we can't. If x minus 2 equals 3, doesn't mean that x plus 7 is 1, which it would have to be in order to get 3 here. What we used before was unique to having a 0 over here. If we got two factors, the product of two factors equal to 0, two or more factors, then each factor will give us a 0 if it's 0. But in this case, that's not so. So we're going to have to multiply this out, and we're going to get x squared plus 5x minus 14 equals 3. Subtract 3 from both sides, we're going to get this. And then we say etc., because at this point again we use the quadratic formula. What about the equation 2 over x plus 4x equals 12? If we multiply by the common denominator, and that's straightforward, we get 2 plus 4x squared equals 12x. This is a quadratic. All we've got to do is subtract the 12x from both sides and rearrange the order of the terms, and we have, again, a quadratic that we can solve easily. And what about this equation? Well, again, we multiply both sides by the common denominator. We have a 4 and an x minus 3, so we'll multiply both sides by 4 times x minus 3, as we see here. And then we distribute, and we obtain what we see here. Okay, and the distributive steps are fairly straightforward. Of course, here we've got to multiply the two binomials and then distribute the four maybe. But in any case, when we get done multiplying this out, we're going to have an x squared off of this, and we got an 8x squared over here. It's pretty clear that we're going to have a quadratic equation, which then we're going to simplify and use the same sorts of steps that we've already seen.